What we're going to do is continue the story so this is now the third time that the two of us have talked. The first time was sort of, bringing up to this slide here, which is when the 6502 is released, presented at WestCon, was it 75?
75.
75, right. And the 6502 took over the world at that point. It was a little more bumpy since then, but there's some more interesting stories about that. So I'm going to ask Bill. So this was just an absolutely wonderful show. You ended up having to sell these things off the show floor and so forth, but you took the world by storm at that point, right?
Right. Yeah.
Very good.
Well, we couldn't actually sell them on the floor at WestCon. We had to invite people to our suite at the St. Francis.
Right, okay, yeah. Mm-hmm. But it was wonderful, and you had crowds and all the rest of this wonderful stuff going on.
Right.
So what happened next?
What happened after the show?
Yeah. Well, what was the arc of that? It seems like you guys were just, controlling the world at that point.
Yeah.
Wasn't so perfect, if I understand.
Right. Well, after the show, of course, we enjoyed the show. We enjoyed all that, and then the wheels came off of the team, actually. So, and actually, the way I heard it at the time, although listening to the talks that I just listened to, I got a lot of information, the background information from what was going on at the time. But what I had heard is that Commodore bought up about 2 years worth of calculator chips, and to build that many calculator chips, then what happened is they built up the staff at MOS, and then Jack just shut off the purchasing of the calculator chips, basically forcing MOS to try to find money, and Commodore came along and said, hey, we'll buy you. So that's how he kind of took over MOS. Now that was what I heard, but what I heard today and what I've heard since then, and with the book that what's his name, Brian Bagnall wrote, I see a different picture than what I remember at the time. So,
with something as complicated as that, there's probably many different ways to
many
sort of see what's going
stories,
on.
Yeah.
Okay, so Commodore somehow takes over MOS, whether it was above board or whatever.
Well,
yeah, not clear.
It was a strategy.
Okay, very good. So what happened to? So I understand that calculator chips factored fairly strongly in your history immediately after you were with MOS.
Right. Well, what happened was, I don't know what the sequence was, but Rod left. This is after the show. So that show was in September of 1970.
This is Rod Holt, who was one of the...
Rod Orgel.
Rod Orgel, sorry.
Yeah, Rod was one of the inventors. And so Rod, I think, probably left first. I think maybe Chuck left next, and Terry. By the way, Terry just passed away 3 weeks ago. And so I would like to take a moment just to think about the three people that were instrumental in creating the 6502, Rod, Chuck, and Terry. In that sequence, they've passed. So with the team leaving, breaking up, I ended up leaving around March 1977.
Okay.
So what's interesting is the calculator company, MOS was a calculator company, chip company, one of the most, I guess, probably had the largest sales of calculator chips other than at TI, independent. But when the company changed from MOS to Commodore, then the focus you heard about today, if you were here for the talks, which was quite fascinating. I really learned a lot about what was going on that I didn't know before. But anyhow, So apparently they lost their calculator designers, and then Jack is saying he needs to get some CMOS calculator chips because Toshiba was charging him twice what the Japanese calculator companies had to buy the same chip for. So then he wanted to hire me, and that was in about February of 1978. So I had left March of 77, and then I'm working for a consulting firm called ICE, and then Jack comes back around February, but we didn't agree until May of 1978 to design these calculator chips that you see. Well, this LC5K3 was the calculator, I guess what Commodore called, and Toshiba had the chip that was in it. So that was the first project I did on Jack and I met in Las Vegas and shook hands, and that's how we got started. But anyhow, that's the 5-function calculator that he had me duplicate what Toshiba was selling.
Okay. Was that a CMOS chip or an NMOS chip?
That was a CMOS. So that was my first, well, that was my second CMOS chip. I had done a redesign of a cardiac pacemaker chip when I was at ICE.
Oh, okay.
But yeah, this is CMOS, metal gate.
Okay. Yeah, makes good sense. Yeah, I think I managed to find a Toshiba chip around that era.
Well, I'm surprised you found that calculator.
Yeah. The way it works is that if there's any collection of people who collect things, you can find them now on the internet. They have their own website.
Oh, okay.
It's like old computer collectors. They're kind of strange people.
Virtual museum on anything.
Exactly. Right. Okay, so you had designed, well, let's see. So I understand that somehow Las Vegas and a hotel room somehow produced the calculator thing we see on the right here. How did that work?
Okay. Well, that's a scientific calculator. That was the second calculator chip I designed. This was all new technology. It was a 4-bit RISC processor that could do 4-bit, 8-bit, 12, all the way to 64-bit, so the scientific calculator. So that's the top or the display part of their scientific calculator. I guess they called it the LC whatever. Can't read that.
Yeah.
But anyhow, that's the display, and then I designed the chip that's under that cardboard covering on that chip. But that was the scientific calculator keypad, and Shiraz was the one that did the software for it. But the reason, the connectivity there is that, as I just mentioned a few minutes ago, Jack wanted me to design calculator chips for him. Chuck is the one that was the gateway, so Chuck is the one that contacted me, and then I actually wanted to design the calculator chips while I was working at ICE. But when I talked to Glenn Madeline about designing chips for Jack, Glenn said, there's no way I'm going to design anything for Jack because Jack owes me something. Oh, okay. So then I thought, well, I wonder if maybe I'll talk to Jack or through Chuck, would you, how about if I design these calculator chips rather than starting a new company or anything, why don't I just design them for ICE? And the word came back, there's no way we're going to do anything with Glenn because Glenn owes me something. Oh, okay. So at that point, I don't even have a choice but to start my own company.
Okay.
So it was a handshake, but when I get to Vegas, this is on a Saturday, it was Mother's Day weekend. On a Saturday, I get to the Dunes. I think that's the hotel that we met at. I find Jack at the blackjack table, and Chuck, I don't know how I found them. Actually, I just found them at the blackjack table. Jack's down by $10,000 when I show up, and I don't know what he's betting, a couple of thousand a hand, or yeah, a hand. And Chuck's got his little chips, and he's there with little chips, and Jack's got the big chips, and so I'm watching him play, just hanging out, and thinking, well, this is an interesting trip to Vegas. I'm watching someone play blackjack. So then Jack starts winning. He's up by $17,000 the way I remember it. And he says, well, Bill, I think this would be a good time to go talk. So that's when we went to the room. So that's my story.
So it seems fitting that your chip company was in fact formed over chips somehow, different kinds of
Yeah,
chips.
exactly,
Okay.
exactly.
So whatever happened to these wonderful calculator chips? I mean, good grief, 4-bit CMOS RISC processor and so forth. I mean, you should have taken over the world, and you should have blown Toshiba out of the water and so forth. And I'm not sure what happened.
Well, what really happened was Jack, I think, just wanted to get the Japanese price for the Toshiba chips. Because he was already using them. I think you can see by the display, he had something working there, and that one. So he just went back to Toshiba and said, hey, we own chips now. Why don't you give me the Japanese price?
Okay.
And so he got half price of the chips. So my whole thing with Jack was, I'll break even on the design, and then I'll get a royalty off of each of them. That's how you know I will want you to be successful. You'll be successful before I am from a profit stream. Well, it ended when Jack ended in 84.
When he headed out, yeah, okay.
Yeah.
Okay.
Well, actually, it ended in 80. So that's when Chuck left. Chuck left at 80, right?
Oh, okay.
So when Chuck left, then I think they decided, well, we're not going to mess with Bill anymore, and so we'll just pull up their stakes.
That's kind of scary. Well, so at least you got Western Design Center
Right.
out of the deal somehow.
Right. Right. So I buy this 4,000 square foot ranch style home. That's the home with a 65 CO2 and the 816. And then within months is when Jack decides we're not going to do this anymore. So I have 3 easy $50,000 payments and no customers. Because what I did to get the opportunity with Jack was to agree that I would only design exclusively for Commodore. And so Xerox wanted me to help them figure out, they wanted me to teach them how to design microprocessors. I took in, what was his name? Bud Fry was the CEO, Chief Technology Officer that I was working with at the time. He was in California. And so I took Bud Fry into Xerox, met with them, and they said, we'll give you our latest CMOS process or anything else we have here if we could just have Bill for a few hours a week. Bud Fry looks at, no thanks. And that was the end of that.
Okay. Well, but I understand at some point you did return to Park for a little bit.
I
right?
did.
This was after.
Yeah, this is so now 1980,
Okay.
when they take all the stuff that they thought was theirs and go back to California.
This was Commodore came and
Commodore just, they took everything they wanted.
there was a U-Haul involved, right?
Yeah, just U-Haul and whatever equipment they wanted, they took. And so that's when I thought, well, I hadn't called anybody except that and if I did, I took Bud Fry with me. And I only did one visit to Xerox. So the same time that Steve Jobs is getting the GUI from Xerox in Northern California, I'm teaching Xerox in Southern California how to design microprocessors. And how that came about is I called them, and I think his name was, I'm not remembering it right. Oh, no. Anyhow, the project that he wanted me to do was teach them how to design a 16-bit microprocessor that went into that system, the STAR system. So when I called him, he said, can you get on the next plane over here? And yeah, sure. back with an envelope. He looks in the envelope, and then he turns around and gives it to me. It's a $25,000 check. And I go, it was Bob Markle, that's the name. Anyhow, so Bob says, I say, wait a minute, what's this about? What are we doing here? And he goes, why don't you have a nice holiday season, and we'll get back, and we'll figure it out. And I go, oh, okay. I said, but why are you doing this? He says, because I missed you twice before. I'm not going to miss you again. You're available. Think of this as a contract. And so that's how I saved the day.
Fantastic. And so you ended up helping them with the chip layout to an extent?
Right. They didn't know how to put the chip together, which is interesting. They had a notebook about that thick, about 2 inches with all the cells in it, but they didn't know how to put them together. And because they didn't know where anything was on the chip. So they had, I don't know, half a dozen circuit designers, half a dozen designers, but they didn't know how to put these cells together. They had them all in the notebook. All of the cells were designed, but they just couldn't put it together. They didn't know what the transistor sizes should be because they didn't know where anything was. So I took that notebook, went back, I found a Xerox scaling or reduction copier, copied each of them, put them together. It was 16 bits, so I'd put 16 cells together, and I put it all together in the schematic, and the schematic is the guide for the layout. And so then the next time I go back over there, I roll out this big, long drawing. They go, where'd that come from? I go, your notebook is now on 1 page. And so that's how I could figure out where things were, and I could figure out what transistor sizes, so I gave them transistor sizes. And my wife, Diane, here, is who background is psychology and and so I taught her and 2 others how to design CMOS. And at the time, I think I was using their design rules because I think that may have been an NMOS design. But anyhow, so Diane learned how to design integrated circuits in 5 weeks, but also she had to learn how to extract the various parasitic capacitance and transistor sizes, plug them into our simulator, and then give me the results. But
wow.
So yeah.
Yeah, very impressive. I remember the few sort of schematic-like things you've shown me about the various the schematics you've shown me were actually laid out very much like the chip was.
Right.
And I've always found that's unusual from what I've seen of other designs.
Right.
That it's usually just logical, and then later it's a mess.
Exactly. And so when you want to, let's say, figure out where things are, because the capacitance of the interconnects and where things are connected to, you want to know this is the floor plan. It's like the architect draws the building and then the builder builds it. And so that's that schematic, and that's the part that Xerox didn't know how to do. And anyhow, that's the key to the success. Yeah.
Neat stuff. Okay, and so of course the next logical step in the story after Xerox PARC makes it so you can at least pay a couple more months on the rent or whatever it was.
Right.
Of course, the most natural thing is telephones, right? This is the most logical progression of this story, right?
Well, turns out it is, but it's not that simple. As it turns out, what I was doing as a consultant for integrated circuit engineering was, one of the things I did was reverse engineer enough of the circuitry of every popular microprocessor of the day. And that was for a contract to fulfill the Rome Air Development Center in New York, I think they are. But they were asking for a third party, meaning the company that built it. They didn't need any more information from them. They wanted a third party, and this is integrated circuit engineering to evaluate each of the microprocessors. 5,000 processor. We did about a dozen of them. The H2 was an interesting one. That was a CMOS one. And what was really strange, out of RCA, they had like if you had an inverter, it was a circular transistor for the N channel and the P channel. And then if you had a 2 input, then there would be 2 circuits. And then a 3 input would be 3. You can't really design that way. And the reason why CMOS processor was built is because they didn't know how to shut off the channel. And then the other thing is that if you go from the N channel transistor to the P channel transistor, and it's a silicon gate process, then you have to go from the N channel to metal, then over to and drop down on the P channel. So it was both the P channel transistors had a P channel or a P type polysilicon. So if you want to go straight across, you had to have a unipolar doped poly. Well, as it turns out, GTE, going back to GTE had licensed a process that was oxide isolated so they could shut off the channel. So, and that was Mitel. So they had process and also licensed the 6802. So they had both the 6802 and the process. And I'm thinking, oh, this is cool. Well, then I find this out. I call the sales office in Southern California for Mitel, trying to find out what they're doing, because this was a new process that I hadn't run into, and all that reverse engineering I did. And what happens then is that they want me to meet them in Ottawa on Sunday. And I'm thinking, oh, all right, I can do that, but that's my last $500. So I spent my last $500. The bank, my cards and everything are maxed out. And so I meet them in Ottawa. I left with a check in hand again. The design group in Tahoe, they fired the whole design group because the chip came out, the 6802 came out running at 250 kilohertz, and they wanted me to speed it up. And so I got the contract to speed it up. This comes back to this, because what happens then is GTE now wants me to fly to Belgium to talk with their division to find out what we would do for a 2-chip system with the 6802. The 6802 plus this other chip is going to go into these key systems that ended up being Intertel in Arizona actually used the chip that I designed. But going back to that, so when I came back from Belgium, I realized that I could build a single chip if I used the 6502, but it would be a 2-chip if I used the 6802. So when I gave them a quote for doing the 2-chip system, there is no 6502 at the time, and I gave them a quote for a 6502 1-chip system, same quote, and I left there the day that I met with the head of the semiconductor division of GTE we're going to do it with the 6502. And that was before the actual 6502 existed. So that's how this 150, and that's the result of the single chip telephone communications terminal unit.
Oh, before the 65CO2 existed?
Yeah, I built the 65 CO2 in a single chip first, and then I 6502.
Oh, okay. And it was had they already, so the 6802 was the Motorola chip that you guys had destroyed with the 6502. Had that already been ported to the CMOS process at that point? Oh, the X6802. Okay. But it was clear that that chip had substantially more transistors in it than your 6502 had. Why? Wow, okay. Yeah. Mm-hmm. Yeah. So that sounds like another very, very lucky, useful thing. Suddenly there's a nifty new process you get to play with, and you get to re-implement the 6502. So give me a rough idea. So the 6502 existed in the NMOS form and
Correct.
so forth, but you didn't have the CMOS version yet.
Right.
What kind of advantages would the CMOS process have
Well,
over the NMOS?
well, first of all, it ended up being faster, lower power, and what I did because I looked at them all.
Ah, hmm.
To make static by having and
Okay. So a mix of dynamic and static things
yeah.
to make it
So
actually work.
all of my
Okay.
chips are fully static.
Oh, okay.
Yeah.
Neat, neat. And with this new GTE process.
Mike Fox and set it on the wheel.
No.
Oh, this thing.
So that's fantastic. So suddenly, Western Design Center has a new lease on life,
Right.
Because you have a patron, a marvelous process to target, and an application. And so let's see. This is the 65 SC150 chip. Was that
Right.
the first one that came out of this agreement? I can't remember.
Yes, that was the first, and then because I carved out the 6502 out of it, and then I designed all of the NMOS parts now in CMOS. So if you looked in the GTE microcircuits data book, you'll see all of those we designed at Western Design Center.
Ah, okay. So yeah, I was hoping that I captured them here. So this is like the 21, the 22, the VIA.
Right?
You've got the Riot.
Yeah, that was used in the Atari game, 32.
Yep.
So, yeah, and so the deal that I cut with GTE on the 150 and on the all of the chips, when I went back to and I sent them the contract for them to sign for doing this, they come back and go, wait a minute, this is like a license. So you own this. I go, yeah. Oh, wow, we were thinking this was just going to be a development contract. Well, it is. I mean, I'm developing it for you, but I own it. Oh, this isn't going to work. Oh, what's not going to work? This is going to, we just had a corporate meeting in Stamford, Connecticut, and this has got to be passed by the board of directors because this is a license. Oh, okay. Now I have no money. So I'm playing poker. I'm like, well, we'll just have to wait for your next meeting. And so I drive back, and by the time I get back to the office, they said, well, we think we figured a way we can do this here without the board passing it. Oh, okay. Just sign the contract, we're good to go. Yeah, so it was really one of those things where that made the difference.
Yeah, I was going to say how you managed to keep the IP that you developed and all of that. That's
Yeah.
a stunt. Very good.
Well, yeah, well, they didn't have any other options, I guess, huh?
Very nice. So this 150 chip had let's see, do we have a pointer here? Yeah. So we've got the 65 CO2 core here, and then you've got some RAM and ROM and some other peripherals around it. Is that
Right.
So this is the one chip solution you were talking about.
Yep. And so a guy named Larry Hiddle, Comlog, by the way, Larry is someone that you probably haven't heard of. I don't know, I don't think that there's anything in Brian Bagnall's book about him. maybe.
Right.
But Larry started the first terminal company, Courier Terminals in Phoenix. And he was the one that set up, I think, the first time-sharing terminals at Dartmouth back in the, whatever, the 50s or 60s.
Must have been like 50s
But
or
it,
60s.
yeah, and that used the GE 225, I think, GE computer. But so Larry is the one that did the software for this, and Larry is the one that helped me with the instruction decode of the 65CO2. And
Okay.
he also did the monitors for our 134 chip and the 265 chips that we sell to this day. And by the way, Larry got $2 per chip royalty because he did the code for that telephone.
That's impressive, because
Yeah.
I'm wondering how expensive that chip was at the time. It was more than $2, but
Yeah.
anyway. So one of the fun things I've learned from talking with you is, in fact, there's quite a substantial 6502 family out there, such as this 150 that I didn't know about and so forth. Here was another one that I found amusing, and I think he's actually selling a single board computer based on this, 300 feet that way or something like that.
Oh.
This is the Rockwell 6511Q.
Right. Now that, yeah.
Yeah, so how did this come about? So Rockwell was making 6502s.
Well, if you look at that, it says right there, it's NMOS, right?
Right, okay.
So it's an NMOS chip, but I also license them on the CO2.
Ah, okay.
So, but this, see the set memory bit and reset memory bit, branch on bit set and branch on bit reset. That is what Rockwell called their bit manipulation instructions, which I added to the CO2 because Rockwell wanted me to add that to them.
Ah, okay.
So if you see the Rockwell 65 CO2, which I know a lot of, well, I know that some of the, what do you call them, the homebrew computers use the Rockwell chip, and they like the Rockwell chip.
Okay. So had they designed these new instructions into the instruction set, or did you put this into the?
No, they designed it.
Oh, okay.
Into the NMOS. They
okay.
changed the NMOS, and then I changed the CMOS.
Ah, okay.
Yeah.
Okay. Sounds good. So we're looking now at this is the original Mac 128.
Right.
And so that doesn't have a 6502 in it, but I understand you had something to do with
Right.
the Mac 128 in one form or another.
Yeah, so what happens is they use the 68,000 and the mouse interface, which they're made popular, right?
Yep.
That used the 65C or the 65C22,
Ah, okay.
and that was from GTE.
Ah, okay. Sounds good. Yeah, I went digging, and you can find what purports to be an original schematic here. And yeah, sure enough, on the right, it looks like the
Yeah.
6522 is there.
Yeah.
And I even managed to find, so apparently this is the mouse circuitry on the original Mac, where they used a couple of bits onto the 6522. So what had to change? You had to modify the 6522 a little bit, right?
Yeah, they were using it with 68,000, and because there's 68,000 is an asynchronous bus, a lot of stuff happening that are not valid memory states. And so as a result, they would be addressing different registers by accident in the VIA. So they wanted to control that if you change the addressing and it was not valid, that we'd always go to the same register. So I changed it so that it would always go to this one register. And then the other thing is that they had the port pins for the serial interface going to they were conflicting. So you'd have the two outputs fighting, and so they wanted me to change it so that if they did fight, become indeterminate, it wouldn't be invalid data. So I changed that part of it, which is transparent. So I made the changes to it. And I think we're going to see something else of what they did, one of your other slides.
Yeah.
But anyhow, I made those changes. I did this so GTE could supply them with the chips for the Mac that they wanted. And then later they called me and wanted to give me something.
Yeah, yeah. No, that was very nice. So well, let's see. It wasn't Steve Jobs who called you up and asked you to do this, but it was
I've
somebody
never-
working
Yeah.
with them. Yeah, yeah. And so you'd heard about some funny thing happening at Apple, and you had, well, let's see. You had started thinking about trying to do a 16-bit thing, but Apple was very fond of 68,000s at the time.
Right.
Right.
Yeah.
And you had gone and spoke with them and said, oh, of course,
Yeah.
you need another Apple II with a 16-bit processor in it or
Right.
something, right?
Yep.
What?
Well, they said they had their 16-bit processor. It's called 68,000.
Ah, okay.
Yeah. And so they didn't want to use it.
Oh, that's no fun at all.
No. Well, yeah, disappointing.
Yes, quite. So
So then,
my understanding is the next chapter in your story somehow involves a card table?
well, what happened was because I had contracts and I had to make good on the contracts, we never changed the values. I gave bids out on what I was going to do. I never changed schedules, never changed any contract values or anything. So that card table, which is not exactly the same, but is similar to that, is where at home I would design the 816. So the 816 was designed on a card table outside of hours so that I could keep the focus on the contracts, and this was a risk process. You know, I was taking a risk in doing this, but I wanted to do it.
Okay.
So
You started working on this and you didn't have customers lined up or
No.
direct applications. This was just, the world needs this.
nobody wanted it that I talked to. So, but I knew it was going to be a good thing.
How disappointing.
Yeah.
And so let's see. This is we've got a little bit of inception going on here. So here you are showing off the 6502 layout. Excuse me, 65816
816, right.
layout. This was a few months ago,
Right.
and this was the first public display of this particular printout. I thought
Right.
that was kind of neat.
Right.
And this had its gestation on your card table.
Well, it started there. Yeah.
Started there,
Yeah.
right? Okay.
So then I did the schematic on the card table, and then I had my sister lay out the entire first draft of the whole thing. So that's a brother-sister design, the 816. Now, Diane's here, and she is the mass designer that has done work on all of our chips. And
okay.
so she's,
Right. So this is like a family processor, a family business
well,
processor.
it's a family of chips, and it's a family.
It seems naturally to develop it that way.
Yeah. Yeah.
Yeah. Well, but we know, many of us know that something changed a little bit in Apple, and they, they were happy with the 68,000 for a few years and so forth.
Right.
But apparently came to their senses at some point.
So,
Let's see. Yeah. Before we talk about that, this is some specs about the 816 that I pulled down off of your website.
right.
Where did these numbers come from?
Well, GTE licensed the CO2, and then they licensed the 816. But what happens is they knew that Steve Wozniak was coming back to Apple for the 816. It was rumored. So that GTE wanted to be in line to supply them chips. So what happens is after I have licensed them on several chips, and I think they had the 816 and the 02 early on before Rockwell never licensed it. But anyhow, one day they tell me, Des Sheehan, he got his PhD from Stanford, and he was the head of technology at GTE Microcircuits. But anyhow, he says to me one day, he says, "Oh, your microprocessors outperform the 8086 and the 68,000." I go, "Oh, really? Oh, I didn't know that." He says, yeah, and here's the information. So he had a guy named Bob Norby did this. But anyhow, he showed me this, and I go, oh, look at that. So, well, I guess they didn't do as good as they could have. And so that was my comment, but I'm saying, well, you can't go any faster than what I'm doing it unless you want to, complicate.
Right.
Yeah.
Speculate or all these other
Right.
things. So roughly what year were these numbers from? Do you remember?
Would have been about in 84,
84? Okay. Yeah, that
84,
makes sense.
85.
Yeah, yeah. The Intel processors were a little pokey at that point.
Yeah. Oh, yeah, they've, yeah, they've done a lot of work.
Yeah, that makes sense. It was striking for me, and as I imagine it is for many of the people in this room, right? I'd gotten almost to the point where I'd memorized the cycle counts on the 6502, since this is how you coded stuff on the Apple II and make it go fast and so forth.
Right.
And when I first saw the things on like the Z80 and the X86, and I said, what are they doing?
Yeah.
Right. And microcode, I assume, is the answer, but it's taken a long time.
Well, microcode's part of the answer, but I think the other part of it is that, maybe that's the answer. Right now, what I saw was that they were doing things using more cycles than they needed to, in my opinion. And when I did the reverse engineering of some of this stuff, I thought they could have done better. And obviously, they have done a lot better since
They've had a few more people work.
Right.
So I understand that, so you made this modification to the 6522 VIA that
Right.
ended up in the Macintosh, and of course that's why it took over the world eventually,
Yeah.
just because of the mouse
Yeah, just
being there, something like that, yeah.
Yeah, sure.
And so you decided to go to Apple and, well, you got something for the effort, right? What did you?
Well, yeah, this is, yeah, so through an intermediary, Steve Jobs wanted to give me something. I don't know why he felt compelled to do that, but they kind of were insistent. I said, well, no, I didn't need anything. I just wanted to make sure that GTE would get your business, make the changes, and it'll be transparent, so none of my other customers are going to suffer because we've made a change that's going to have a problem. So then he said, well, we really want to do something for you. I said, well, I heard, now this is before the Apple II GS came out, right? And so I said, well, I heard that there was a Apple II GS development system built so that if a journalist came into your development office, they thought they were looking at an Apple IIe. So I said, I'll take one of those Cortlands. That would be, I'd like that. So then I got this Cortland sent to me.
Wow, okay. Yeah, and I've never seen one with this badge before. So the photo inside, it actually looks like either pre-production or production 2GS motherboard.
Right.
And there's your chip.
Yeah. There's
That's
the
pretty
chip.
good.
So.
And you were, so
Oh, that's
this,
the 6 megahertz one. Huh.
yeah. Why doesn't it go faster, right? But I understand also, so that this was a bit later in the game, and so obviously at some point you realized that, oh, they actually were going to use the 65816 at some point.
Right.
How did you learn about that?
Well, what happens is I visited them while I was probably halfway through the design. And I had a guy named, what's his name? I'll come up with it. He was in charge of the Apple III project. He visited me, but he was just like, okay, what are you doing? And then I asked him, do you have any ideas that you want to put into the 16-bit version of it? Well, they're not going to use it, but, we'll give you a little lip service. What is it? Oh, I almost had his name. Anyhow, so what happens is I visited him then. After I had done more work, I went up to Mountain View and met with them, and they said, well, we're not our 16-bit is the 68,000, so we're really not going to use it. I came back with tears in my eyes. I go to my team. I had my team pulled together, and I'm going, well, they don't want it, but we're going to finish it because it's the right thing to do. So what happens is then I don't hear anything more from them, but I see articles, Apple IIX and things like this. And so then what I did, we finished it, and then we started, we GT licensed it, and then I got together with Steve Wozniak one time, and we had a meeting. And I had licensed NCR on the 02 and thinking that they would license the 816 as well. Well, both NCR, Bob Jones was the person from NCR in Fort Collins, he comes to the meeting and he knows he's not going to be a second source. But I don't know that. And so we're in the meeting with Steve Wozniak and Des Sheehan, he's the real champion of this whole thing. I mean, Des Sheehan is magical. But anyhow, we're in the meeting with Steve and someone else. I don't know who the other person was from Apple. But what happens is GT says, well, we're in. We're going to be your source. Well, we need a second source. So NCR, you in? Bob Jones says, no, we're not going to license the 816. I'm going, Bob, you knew what the meeting was about. What are you doing here? And I look at Steve and I go, Steve, you have custom chips, right? Yeah. AMI builds them, right? Yeah. I said, okay, well, I'll have AMI build the chips for me, and you get to choose the process. I'll put it on any process you want. If AMI is not the one, we'll do another company. But I'll be your second source. I'll have them build it. I'll supply as the second source. GT is your first source. Then we went to lunch. So what happens then is that they design the Apple IIgs, and all I hear is rumors. I don't really know if they're really going to do it, even though we had the meeting. So Dan Hillman, I think, is the name of the guy that was in charge of the 2GS project. He calls me, says, Bill, could you come up here? I'm thinking, I don't need to hear one more time that we have our 16-bit processor and it's a 68,000. Thinking, okay, I can be on this roller coaster, get on the airplane, fly up there, get into their offices, and here's 3 or 4 of his engineers. They're standing in the room. He's standing. I just walk into the room, and he hands me the motherboard of the Apple IIgs. And I hear this gasp like, I haven't even held that yet. How does he get to hold that motherboard right now? And so then I left with a big smile. I knew it was happening.
Very nice. Very nice.
Yeah.
Very good. I brought one of your babies along today.
Oh, you did?
Yeah, I mean, this is what all the well-dressed folks are wearing. So this was a 6502 badge from a few years ago. And somebody, oh my God, another build my own 6502. Well, I've got to have one of these. So of course I ordered and decided it together. And I think I could change what it says, but it says, badge for VCF.
Oh.
I don't know, you probably can't see that on the video, but anyway. So I would be honored if you'd be willing to sign this.
Yeah. By the way, I'm signing a Rockwell chip.
But they're one of your licensees.
Well, they are one of my
right?
licensees, yeah. And Rockwell, I'll tell you what, Rockwell is one of my most favorite companies. I mean, GT and Rockwell, like, licensed it the same week or something. Let me sign this right now.
Yeah. Let's see. Let's hope I get the right pen. Anyway. Yeah, that almost works. And that's not the right pen.
Oh. Oh, is that a problem right now?
Yeah, the problem is that I couldn't figure out which one was the dead one and which one worked.
Okay.
Anyway, so I'm very proud to have a Oh, that one doesn't work either. Oh, well, close enough.
Well, you know I signed it,
Yes, yes.
It's on film.
We have, yeah, it's visibly worth.
and I'm going to put a date on there. There you go.
Yeah, great.
All
great.
right,
Okay.
there you go.
Thanks so much.
If you find another one, I'll sign another one. Hey, you can put one of my chips in there, and I'll sign that.
Did you bring any with you?
No, but
Yeah,
I'll get one. Yeah, we'll figure it out.
Yeah,
We'll
yeah,
figure it out.
we'll work it out, definitely. Yeah, no, it's great fun. It's like, I don't know what fraction of the people in the audience, I cut my teeth on 60, and I'm not quite at Bill Hurd's level of being able to, memorize the opcodes, but close.
Yeah,
I
Bill
knew-
Hurd's talk was fascinating.
Yeah, yeah, I know A9, but not A2, and so forth. Anyway, from all of us, thank you so much for giving us all of this over the years. And let's see, I guess we have time for questions now, is that? Okay. Absolutely.
Stephen Cass. Stephen Cass, right back here.
Just one question I'd like to ask. The 816 has a kind of an interesting link with the ARM processors, with the folks at Acorn, and maybe you might, and how way that you worked influenced in the ARM. Maybe you want to tell people a little bit about that story.
Okay. So the question, I guess, is how did I or did I influence? Yeah, so, okay, so the Acorn computer, and ARM was originally Acorn RISC machine. That's what ARM stood for originally. Well, Acorn and the BBC, that was their global, or you could call it the British Empire's computer that was to compete with the Apple II, and you could say the Commodore 64. And so what happens is they were familiar with the 6502, so they were looking at the 816 as well, and this is when it was rumored that Apple was going to do something with the 816, but it wasn't fully, what would you call it, acknowledged by Apple. And so Acorn was looking at the 816, and they were going to use that, and then they decided they wanted to leapfrog Apple, and they wanted to do a 32-bit. So Herman Hauser was the investor in Acorn, and so he basically sent Steve Ferber, who I don't know if he's still the head of the Brain Project in the UK at, I keep forgetting names right now, Manchester University. And then there's another guy, Sophie, or at this point a woman, Sophie Wilson. She was the one that was looking at the instruction set for the original ARM. So the two of them came to the US, North America. I think they probably visited Berkeley and or Stanford looking at what they were doing in RISC processors. And so then after that, they came to visit me, and that was, I think, Herman Hauser. I think there's some YouTubes on these three people, Herman Hauser, Sophie Wilson, who works, I think, for Broadcom, and Steve Ferber. So they visited me, and they wanted me, much like, which is interesting, going back and thinking about what actually took place in the conference room in my office that I have now, and have had since the Commodore days, right? So what happens is they come and they visit me, and they want me to design this 32-bit RISC processor. And I'm trying to finish up. This is in the fall of 1983. So I'm like, well, I got to finish the 816. I can't really switch horses right now. And I knew that it was going to be a major effort to support what they wanted. So I basically said, thanks for the invitation to help you, but I don't have, you can do it yourself. And I know that you can capable of doing it. But then they kind of left in a bit of a disappointed that I wouldn't do what they wanted to do, much like what I had done for Xerox earlier in earlier 80. So what happens then is that they leave, and one of my licensees was VLSI Technology. VLSI Technology had a design platform that was really advanced for its day, and so they went to VLSI Technology, a licensee of mine, and Doug Fairburn, who is a photographer, and I think at the Computer History Museum. He may do other things there, but I think he was the one that first did the layout of the first ARM chip. But that was, they left, I guess you could say, negatively inspired, whatever you want to call it, but they left there not happy, and they figured out how to do it themselves.
The story is that they were inspired by seeing how small your company was. It made them feel that it was possible.
Yeah, because here's this one guy that's got a team, but kind of like you guys, you're two of you, so one of me, one. Yeah. Well, that's, they probably have their own opinion about what happened there, but there you go. So, by the way, Ricoh was the first company that I recommended the ARM to. Ricoh, I licensed to manufacture the chipset for Nintendo. So, Ricoh asked me in about 80, I don't know, late 80s, asked me what I was going to do for 32 bits. I had already specified one. I think you can find it probably on the internet someplace, the 832. It was going to be compatible with the 02 and the 816, and so you probably can find a data sheet on that. But I had done some other data sheets for other configurations, following some of the RISC processor type stuff, but not completely so I could be compatible. So what happens is, Ricoh, when I said to Ricoh, well, I have a data sheet, but I'm not happy with it. It's not something I'd recommend. I really don't think it's that good. I think there's better choices. And I said, so what are your other choices you're looking at? I said, just send them to me, and I'll review them, and I'll give you my opinion. So I think they sent me 5 different options. One of them was for what could be considered the National Science Foundation of Japan. It's some kind of a national effort. They gave me something NEC was doing, which was the most powerful computer company in Japan at the time. That was 2. There was one from China, I think, and I'm not sure what the other one was about, but as I recall, it was 5 of them. But then there was the ARM. So I looked through all the specs, looked at all of them. My answer was ARM. You should get the ARM. So I think they got the ARM, and the rest is history, right? Yes.
Okay, so Jack Tramiel's quote is, "Business is war,"
Yeah,
and he got pinched badly in the early days with the calculator chips,
right.
TI being stingy with them and all.
Yeah.
So I often wondered, did Jack ever think about keeping the 6502 to himself instead of second sourcing it?
Well, Jack wasn't, no, what happened was Jack came after it was second sourced.
Oh, he did.
Yeah,
Okay.
so Jack wasn't in the picture when we licensed Centertech and Rockwell.
Ah,
Yeah, that's,
he might have been chagrined, yeah.
he may have kept it to himself. He could have. He probably had that.
Were you involved in the licensing while it was still at MOS?
No, the license, that's Chuck.
Okay.
That was Chuck. And by the way, one of the reasons why the team broke up so rapidly after the introduction was because someone, I think it was Rod, but it may not have been, it might have been Terry Holt, but somebody realized, and I was kind of naive about the whole thing, and that was that our contracts that we signed, we all thought we were going to get rich. We really did. we were going to get a percentage of the profits. And someone must have figured out that, wait a minute, when are we ever going to have a profit here? And that's what I think caused the team to break up earlier than maybe expected. But for me, I was looking at it just because I just loved what I was doing. I designed the peripheral chips, the microprocessor. I just love designing and empowering others to build systems like the Bill Herds of the world, build Chuck Peddles and Wozniaks and the Nolan Bushnells. I love that. And GTE and all of my other 60 licensees. So that's what I enjoy doing, and I continue to do that. And there's some really fun things that are happening right now that nobody's ever talked about. Oh, there was one that it's a pragmatic relationship partner. So anyhow, there's a lot of stuff going on right now, but it's still the same thing. I've got system level products that people buy. There's single board computers, but there you have it.
I just had another follow-up. So it's that question about like the 6502 has become a little bit like the doom of processes, and that the question is, can you run Doom software on it? And if you have a CPU process, it's like, can you do a 652 on it? Or like, it's a very popular target with FPGAs. Everybody likes to implement the 6502 on an FPGA, and the 6502 core turns up in so many places. In modern products, not just sort of the retro homebrew components that we like. So what are some of the interesting places you've maybe seen the 6502, and why do you think it remains such a popular choice? Even though at the time its instruction set was seen as a little weird when it first came out, but now it seems to be like the natural choice for so many of these re-implementations to this day.
So the question is, why are so many people interested in building? Yeah. Well, I think I made this comment, and maybe you even put it in your article in the IEEE, was that there's a certain love for the technology. And I think you can feel it. I think you just, there's something about it. And I don't know if it's because of its beginnings. I don't know if it's because it's known as having been the platform that the PC and the gaming industry was built on. I think that has something to do with it. But the other part of it is programming it in assembly language is just, there's a joy associated with that. And also, if you study this, you saw the benchmarks I just showed you. I mean, if you're using small systems, that you just can get a lot done with that processor. And so people that really know about that, I think, enjoy doing that. And I think what some people might think of anomalies or why does it work that way, everything we did had a reason. We didn't put anything in there if we didn't have a good reason. So I think maybe some people actually see that. I mean, you compare it to 6800, just as an example. 6800, which came before the 6502, you got an opcode fetch and then the high byte of the address. And that because it looks good on a piece of paper. And then the low byte of the address. Well, you can't do anything with the high byte until you get the low byte. If you're going to do an indexed operation, you have to wait to get the low byte to add the index register to it. 6800 had one 16-bit index register. And you go, well, if you're going to move something from point A to point B in the memory map, you need really two index registers. So that's some of the thinking that Rod and Chuck and Will and myself had the experience of, this is a better way of doing it. So then if you look at that and you get the performance there, then I'm saying there's a lot more you can do with that little processor, and you can have fun doing it. I want to say also, there's something happening right here that in the world right now, and there's a guy named Ben Eder. I don't know, he was going to come to this conference at one point, but Ben Eder is a master teacher, and he's the technology guy behind the Khan Academy. So there's an interview of how, I think it's Hal Khan, one of the founders, two brothers founded the Khan Academy, or was it just the one guy. Anyhow, the point is that Ben Eater is the one that set it up so that they could do the technology behind their education model. And so that's what he's using. And the Ben Eater tutorials are really interesting. And I think he's finding a lot of people. We supply him the chips, so we know how many people he's found. And so he's finding people, is all I'm saying. He's finding people that want to learn and build their own computer. And so he also makes a pitch for breadboard computers. So it's this kind of stuff, Stephen, that I think makes a difference, and people can feel it. And that's why I think there are more people that want to work with the technology. I want to also say something that happened. The set-top box industry started with analog set-top boxes. Gerald was the supplier of that. The Gerald people, the engineers that designed the set-top box for Gerald also were the designers of the original PIC microcomputer, so the PIC system. They came to me and licensed the 6502 so they could get a better cost picture because they were buying a Mitsubishi equivalent of the 6502. So it's just some of this interesting thing that's in the background. You may never known that Mitsubishi had a 6502 type processor. The other thing is that, for instance, we sold probably at least a billion games through a company in, it's Nuvoton. But before that, I think they may have had a different name. But anyhow, probably a billion games went out. These are little 5-function joystick games that you buy at Walmart or wherever you buy games. There's a company that also, I don't know if it's called Sun Plus or something, in Taiwan, that had a 6502 equivalent. And so some of these companies that build the 6502, you may never heard of it, you may not even know that it's in the thing. So I have no idea how many systems have been sold, but when I add a couple of billion for modems from Rockwell and a couple billion from on disk controllers that Rockwell supplied, the 6501 I think was used in a lot of disk controllers. So when you add them up, that's where I get the 5 to 10 billion, and I've never changed the number. I just leave it 5 to 10. I think it's big enough. So.
There's another question.
On the Wikipedia page for the 65816, it says that samples were given to both Apple and of the 616 chip. I was just wondering if the 816 was ever in the cards for any other 8-bit lines, because in the retro scene and in the tail end of the Commodore 64, you had something like the Super CPU, which implemented, I think, a version of the 816, and then I think there was an accelerator board that made use of the compatibility. And just wondering if there was just too much competition with the 68,000 and why that never worked out.
Well, 68,000 is one of those those microprocessors that you wish evolved differently. 68,000 was a much better processor than the 8086 in its day. So what changed was Intel and the 8086, and then what Intel did with the 8086 to advance it and the process. And so the reason why IBM, and back in the day when they were still in development, IBM had considered the 816. And I got calls from Boca Raton on what I was doing with the 816. And the reason why they told me they went with the 8086, IBM had designed a 68,000 version of the PC and the 8086 from what I heard from them. And they chose the 8086 because of Intel's marketing and manufacturing capability, and they felt that Intel was higher on the, more advanced from a manufacturing standpoint than Motorola was, and that's why it went to the 8086. So the 816, I think, lost out because Apple never said, hey, if you go, let's go as far as we can go with this thing. What is it going to take to make that happen? That would have changed things. But that didn't happen. And so I'm thinking, what I'm doing with 8-bit and 8/16-bit technology, I've still got a lot of headroom. A lot of what I'm doing right now is this 65 CO2. And in fact, I've been asked to do what I called, in celebrating Steve Jobs, an insanely reduced instruction set processor for systems on labels, plastic system on labels. And that's, I don't want to say anything more than, what would an insanely reduced instruction set processor actually have? Well, I came up with 2 instructions, 2 addressing modes, and 2 registers. That's insanely reduced. So that might happen. I mean, right now, we're looking for the applications for plastic labels, and we're going to find them.
So first of all, thank you very much for the generosity with your time this year, last year, other times you've interviewed with Steve in here, and we really appreciate it, and it's great having you here. Shifting gears a little bit, tell us a personal anecdote story about, say, maybe Chuck Peddle or somebody that maybe isn't common knowledge, maybe something we haven't heard before. Just pick anything you think is interesting that you might want to share.
Well, Chuck and I knew each other, or actually worked in some capacity with each other from 1973 to within days of his passing in 2019. So that's 40 years or whatever. So what happens here is that Chuck, he's one of these characters that just, I don't know, one of a kind. He's a one-of-a-kind guy. But what's interesting is that he actually lived he's the only person that has lived or even spent one night in my office at 2166 Brown Road. He actually lived there for 6 months. And when he moved out, he left behind one of his, penny loafers. So he has penny loafers that he left in the closet with some pennies and some change in it from his pocket change. I was going to have David take a picture of that so that you could have that on the slide for a question like this.
That would have been
But
bad.
the other, one loaf or not a pair? A pair. No, it's a pair. So for a fee, you can try them on. But anyhow, so we donated his bed when he left. He didn't shower there, which is interesting. He just slept there. But he had a membership at a sports or exercise place. I don't know which one, but he would shower there, he'd exercise there, and then he'd sleep at our offices. But the other thing that's really interesting, and I didn't know this until probably 6 months ago, but David Gray, who works with me, when you buy chips from WDC or boards from WDC, David Gray has a hand in every one of those. So what happens is, David says to me, oh, by the way, there's something else Chuck left behind. What would that be? Well, you can get at Home Depot, you can get an 8-foot-long thing that you'd hang in your closet to hang clothes on. It's about maybe an inch, maybe an inch and an eighth or whatever. Dow, he cut that in half, and he ran with those, one in each hand, the other half. So these are 4-foot, these are 4-foot things, and he left those behind too. So we have those. But why did he do that? He was in Russia one time, and I guess a dog chased him, or I don't know what happened, but he didn't feel safe anymore running, even in Mesa, Arizona. And so he'd had these two, and he must have looked really interesting. I wish running that. Can you imagine that?
Why do I not have a photo of this for the? Yeah, I imagine Chuck's shoes would be very hard to fill.
Absolutely.
What was the reason for the SO pin? What did that?
SO, set overflow?
Yeah, I looked at the code in the 1541 drive that uses it, and that makes sense, but how could you have known in 1975?
Well, the set overflow, is also another name for it. The CPS, the reason why I didn't know what CPS, I could have guessed that it was Chuck Peddle's special or something. But SO also was Sam Orgel. And Sam Orgel was a dog that Rod Orgel had. And so then we would say it wasn't really set overflow, it's Sam Orgel. But in any event, what that was supposed to be is fast I/O. So in other words, you could branch on whether it was set or cleared. But then that would be you had to know what you were doing in the system because it's really for math operations, right? There's an overflow. And so I don't know who came up with that. I didn't come up with that, but Chuck apparently did. I don't know if Rod would have. But anyhow, the set overflow is you set or clear the overflow with that pin, then that means you can branch on it. That will help with certain kinds of things you might want to do. Yeah.
So you're overloading the overflow bit on the math, and you're saying we're going to use it for I/O as well.
Right.
This pin.
Yeah, you really have to know what you're doing and make it, so you don't have
We
a...
did end up using it in a Commodore and one of the disk drives. We did a branch and overflow clear to star, so it was in theory the fastest loop we could make and catch a signal from the disk drive rewrite things. Prior to that, we had used NMI to be the fastest response. So it did get used.
So slightly less latency than an interrupt.
Yes,
Like about
and it was
12
very
clocks.
pretty predictable time because the loop was pretty small. So it didn't jitter as much either.
Yeah. I didn't think anybody actually used it.
I think we used it on one drive only, and yeah.
Well, it's useful also because, so overflow is created on every add instruction or subtract instruction. I think that's the only one, right?
Yeah.
But the only place where it shows up is if you branch on it.
Right.
It doesn't affect anything else.
No, the overflow, branching on overflow, set or clear,
Right.
Yeah.
Right.
but nothing else happens.
So yeah, serial I/O.
So some variants of a 6502 ran at 1 megahertz, and later ones ran at 2 megahertz or faster. Was that the B or C variant? I can't quite remember. But why was it that so few of the popular users of 6502 upgraded? Atari seemed to use the 2 megahertz version, but Apple didn't, at least not until the Apple IIc, and Commodore didn't maybe ever use the faster versions. Why was that?
We'd have to ask them, but, oh, there you go.
So we did use the 2 meg version in the 128. You can go 2 megahertz in that. You have to turn off the big chip and use the 80 column only, and then we grabbed both DRAM cycles, effectively 2 megahertz. So it was a wonderful thing.
Any idea why others didn't? Why?
They weren't Commodore.
It was the
Well-
same story in the Apple II, that Woz was using the alternate
Yes.
things, and so if you ran it, twice as fast, you get twice as fast RAMs or something like that? It would be
Yeah.
tricky to make that work.
So, what's your name?
AYAL.
A
AYAL.
AYAL. Okay, so I was hoping there was a picture of the Cortland in my display case, because there's something in that display case which can tell a story. There's a cup, it's an Apple cup with some bits on it. It's a cool looking cup. And that cup came from Jean-Louis Gasset's office. And this is tying back into your question. So what happens is, we're at the Moscone Center, I think, and this is about Apple II and education, and a lot of teachers there, and a lot of people wanting faster Apple IIs. They loved the Apple II. Faster meant they could do more things with it or whatever. And so I was being invited to the Apple II developer whatever meeting. After this session with Apple and Jean-Louis Gasset, I don't know who else may have talked there, but it was all about Apple II. So Jean-Louis Gasset was the head of technology at Apple at the time. So he's on stage and he's talking about the Macintosh. This is the wrong crowd to be talking about the Macintosh. We're Apple II guys. And so I'm sitting with the developer, the developer group. We're all in a row, and he's saying something about we can't get faster Apple IIgs. I mean, Apple 6816s. We can't get faster ones. Now, you saw the 6 in there. That was the slowest one. And so what happens is they're running at 2.5 megahertz in the Apple IIgs. And so I knew something was going to go down here because the Apple II developers are not happy with what Apple's talking about with Macintosh. They have their 16-bit. Well, we want our 16-bit to be used more. And so I had in my vest pocket, in my jacket pocket, I had a half a dozen 816s and with the data from the tester. So it shows the speed of the 816 in the tester. So when he says we can't get any faster ones, I'm like, do I get up and say something? And I'm there, and they have like 2 mics set up. Well, at some point, I think Jean-Louis Gasset saw that I was going to make a move to a mic. So he says, we have time for 2 more questions. There's 2 people standing at this thing. So I'm thinking, I'm feeling this rush of adrenaline. I get up, I walk over, I pull out one of the 816s with the data sheet, or the test data. I go up to the second guy in line, and I said, would you trade one of these chips for your spot in line? And he goes, yeah. Okay. So I got the spot in line, right? So the first question, I have no idea what the other question was about. So I'm there. Oh, Jean-Louis Gasset, I have chips right here in my pocket. You can get faster 816s, just so you know. He went berserk. He is like, I don't know what he said or what he did, but at that point, I'm like in shock. I'm really like, this isn't what I would have expected. I mean, really, not in the front of a crowd like this. And so I go back like in shock, like, that didn't work. There's nothing here, whatever. I'm just disassembled. Anyhow, so I go back to the guys. We go back and we go out front. We go out front to go to a meeting on the second floor. They had a room set up. And there's Jean-Louis Gasset right outside. I mean, he went from the stage all the way around. Somehow, I don't know how he got there, but by the time we left and were there with half a dozen of the developers, Jean-Louis doing a Chuck pedal. You come out here and I am going to kick your butt. And I'm going, he wants to fight me. And I'm thinking, I'm not a fighter. I'm not going to fight you, but what's going on here? And he said, no, we're going to go out there and I'm kicking your butt. You can't do what you just did in there. And I'm thinking, what did I just do? Anyhow, we didn't fight. I don't know what happened after that, but I'm like with my buddies, right? And so we didn't go. I don't remember what happened after that, but I can tell you that then this cup that I have, I decided to go in there, and that's the peace cup. And so I went in there with my vice president. His name was Fred McWilliams at the time. We were in the Bay Area. We set up a meeting. We wanted to talk to him about it. And so then, I don't know what we actually did, but he wasn't going to build any faster Apple IIGSs, even though the Apple IIGS did the Macintosh quicker on the Apple IIGS than on the Macintosh. Yeah, and so they were going down a different path. And you know, Apple is the most valuable company in the world. So come on, Jobs and his team did something right. And you know, I'd still love to see like Volkswagen. You know, you've seen the Bug, and different companies with autos especially. They take out the updated Thunderbird and things like this. I'm thinking, wouldn't it be nice to have a 25 megahertz or 100 megahertz Apple II, just because, especially, just because it would be like the old Volkswagen that's updated with latest technology. I'm just saying, maybe Apple, you can hear this. It won't really change your market, but you would have a better PR because you're saying, I'm going to bring back the Apple II. Working with Bill. Yeah, I'll help you. Anyhow, there you go. Thanks for the question.
How did you end up with a cup then?
Oh, so I took the cup. So I took the cup. Actually, I probably said, Jean, you mind if I take your cup? But yeah, I have the cup. That's the cup. That's the peace cup.
Oh, that was coming from him to you.
Yeah. It was.
The way around. I thought surely he'd thrown it at you. Or something.
Oh no. No, he didn't. He wasn't that way. He was calmed down. There was something really mysterious about what went on there. I mean, I don't want to suggest anything other than, how did a guy get from the stage out to the front before we could get there, and we were halfway there?
Well, I assume he hung around Jobs, and Jobs has a reality distortion field around him.
Well, that's what it felt like.
Yeah, I assume
Yeah.
he just sort of, changed the relative speed of time.
It could have been something like that because I just don't know how he got from there to there.
Any more questions?
So out of everything that the 6502 has been put into, do you have a favorite or a notable product that you felt was something that you really liked or really felt was the best fit for it?
Well, I'm here on the East Coast, and there's a lot of fans, and we have Bill Hurd, and we have Michael Tomczak. So this is kind of heresy for here, right? But it's the Apple II. It's the Apple II. I mean, I could say the Apple I, but there's only 100 of them, but the Apple II is what. Well, you've done a lot of studying on the Apple II.
They're kind of nice machines. Some people like them.
Well, the reason why the reason why I like the Apple II is for the opposite reason of why Bill Hurd and the team back here have done what they've done. What they've done back here. I mean, come on. What VIC-20 did, and I heard that today from the guy. And I love the story. I mean, the story that I heard today, I hope you put that online because I'd like to hear it again. Because Michael, if Chuck Peddle had Michael's charisma, I'm telling you, I wonder what that looked like. Because right now, I think Michael was the guy. He was the guy, from what I read right now. Now, I love Chuck. I loved him. He inspired every emotion a human has. Okay? I've been all over the map with Chuck. I mean, really. I mean, in this final year, I decided I'm not going to be angry anymore. I'm just send him, Christmas wishes and stuff like this. I mean, really, it ends up being that you just at some point realize that I own these emotions, and that's the case. But the reason why the Apple II for me is it's stock. It's a stock 6502. It's a stock 816. And so therefore, the customization of the 6510 and whatever else numbers that Commodore came up with. Now, of course, that's what people want right now. They want the stock, actually they want the PDIP version, not the PLCC or the QFP that we have, or even the FPGA versions that we have. They want the 40-pin DIP part, and I just think that's fascinating and enjoyable. And so that's why the Apple II. But the other thing about the Apple II were the slots. The slots, you could expand it in ways that are really tricky, that what WOS did with the slots. And those slots were what the magic was that the teachers liked. They wanted to be able to control things there, and they wanted to have that control available through the slots. And so I've talked with different professors over the years, but there was nothing like that, because the IBM PC slots are really complicated, and they're really asynchronous, and there's a lot of things going on there that you don't even know what's going on half of the time because of all the layers of code or firmware or whatever else. So that's what made the Apple II, in my mind, the special system. And the reason why I choose that over the PET, not to say anything bad about Chuck, but the chiclet keyboard, that was Jack's invention, right? The story about the chiclet keyboard, that was a problem. But it's an icon. I mean, I think it's in the movie with Stephen Hawking. It has one of the old the PET computers in that movie. So it's really got quite an interesting look, and you would think the PET would be my choice, but it's actually the Apple II. Now, one other thing I wanted to say. When you hear about saving lives, and you hear about the millions of people that are kept alive to this day, one heartbeat at a time, that's my CO2. That has to be low power. It has to be static, so it doesn't have errors created if you go through an X-ray machine or down at the airport. So what I'm saying is I licensed about 5 or 6 different companies. One of them was, the first one was L'Oreal Pharmaceuticals in Paris. They had an ELA medical company that partnered with a company in Australia called Telectronics. And so these companies were the first to use my microprocessor for life support. Millions of people, life was supported. So there's something, I think you can hear it in my voice, there's something special about that. But the only time you would hear about it is maybe if I tell you about it, because nobody else wants to talk about it. But I'm indemnified for anything my processor does in those environments, because I've given. Thank you.